There's a third kind of rate distance problem that we're likely to encounter when we're thinking about systems. And that is in a story where someone goes out at one speed and comes back at a different speed. So in this story, Kyle is going out hiking. On the first day, he hikes up a trail to the top of a hill. He goes 3.2 miles per hour uphill. At the top of the hill, he camps, and then he comes back down at 4.8 miles per hour. Altogether, he spends 12 and a half hours hiking. And the question is, how high is the hill? There's only one unknown that we're asked for here. What makes me think I need a system? Well, I know how fast he's going, and I want to find out how far he's going, but in order to find that out, I need to know how long he spends hiking each way. And what are the rules? Well, the rules are distance equals rate times time. Again, we know about his speed up, his speed down, and we know his total time is 12 and a half hours. Oh, there's one more rule that we know, don't we? We know that the trail is the same length no matter which way you go. Now, looking at this system, it really looks to me like it has 3 unknowns. We're going to have to make sure that we model this with only 2 variables because we don't know how to deal with 3 variables yet. But I think that we understand the question. We know what the rules are. Let's see if we can model it. Right. Okay, so the height of the hill is the big thing we want to know. We'll call that D for distance. Right. Okay. His time going uphill, let's call that T for time. His time going down the hill was probably different because he went faster. But we know that together they made 12.5, so his time going down will be 12.5 minus T. Right, if they're going to add up to 12.5, this has to be the case. Now, this is one of those instances of slipping substitution into building the model that I mentioned. And we wouldn't have to do this. We could model this with 3 variables. But the disadvantage is that we would then not currently be prepared to solve it. So since we can model it with 2 variables, let's model it with 2 variables. All right, so the distance he went up is his speed going up, 3.2, times his time going up. The distance he went down is his speed going down times his time going down. So this is our system. We can solve this to answer the question. We're now prepared to solve. Why don't you pause the video and try solving this system? Okay, so even though what we really want to know is the height of the hill, it looks like this system is really well set up to make it easy to find T using substitution. We just substitute this expression for D, and we get 3.2T equals 4.8, 12.5 minus T. So let's see, 3.2T equals 4.8 times 12.5. I get 60 minus 4.8T. Add 4.8T to both sides, and I think I get 8T equals 60. Divide both sides by 8, and I get T is 7.5. Now I want to find D. I'm going to plug into this equation because it seems easier. D is 3.2 times 7.5, which gives me 24. What does that tell me? I'm ready to answer the question now, right? And will t have any part in my answer? No, because the question just asked me for the distance, the height of the hill. How high is the hill? 24 miles.